What are your cameras on?
Hello. Hello.
He's supposed to be in the guy's
Back.
Yeah. He's supposed to be in the
All right. Start talking now. Ready? Everybody listening? Okay, thank you. So we saw the sun. We saw a white sun, right? With sunspot.
Yeah, I thought that was just a mirror.
That spot. Everybody be quiet. If you don't have a poster, there's some free posters for you from NASA. That spot you saw, the white ball was the entire sun, and the spot was the black parts, right? Just like in your glasses. You can see the spot with your glasses on. Everybody put your glasses on again and look at the sun. Walk around a little bit. Can you see the spot?
Oh.
A little black spot, right?
Yeah.
That spot is large enough for you to see with your naked eye from here. And we are 93 million miles away. Remember how far away the sun is? Everybody listen up now. You see the black spot on the sun, right?
Yeah.
That's the same thing you saw. Keep looking, you'll see it. It's a little tiny black spot. That's the same thing you saw in the telescopes, except we saw it really close up. Okay? That is a sunspot. That is caused by magnetic activity on the sun. The magnetic field is so strong in that spot that the light can't even get out of the sun. It has to go around it to get out. Okay? So that's a really cool feature. You'll see it on the news here probably this week sometime, because there's going to be some flares that hit the Earth that are going to cause really bright auroras in the North and South Poles, you know, the northern lights. Yeah. That's where they come from. Okay? Now, who saw in the red telescope? You saw the whole sun, right? And some flames shooting off the edge, maybe? Yeah. Did anybody see a bright white area? Like a white line, like a river of hot plasma? That is the same feature in a different wavelength of light. Okay, that's called an active region. It produces sunspots, flares, prominences, X-ray flares that come to the Earth and make auroras and northern lights and things. That is the same region on the sun, just in different wavelengths of light. Okay, so does anybody have any questions about what they saw? So you can all explain it to me? Yes. Well, it's possible it'll be somewhere between northern lights and complete vaporization of the planet. More than likely northern lights. But the sun is easily, you saw how small it was compared to the sun, right? The Earth? It's easily capable of destroying the entire planet. But it probably won't happen, because you got to remember, we've been around for about 5 billion years, and the sun's been through this cycle many times, and we're still here. So it's unlikely it's going to destroy us. But it is likely that it's going to knock out internet and cell phones for a day or two. Come on in close for a minute. I got a special, hold on just a second. I got a special plan for you. I'm going to tell you how to survive a solar flare that knocks out your cell phone. Who's got a cell phone? Me. Who sends text messages? Me. Okay, now, who sends them in class? Me. Okay, you're fine. Now, here's what you do. Okay, you listen? Watch this. This is a special emergency preparedness. Everybody watching? Yeah. If there's a solar flare that's strong enough for your cell phone to go out and you lose your text messaging, here's what you do. You put down your cell phone. Okay? You stand up. And if you want to talk to little Susie, you walk over to little Susie. Okay? Your friend or whoever you're texting, instead of texting them, here's how you do it without the internet. You open your mouth and you start to talk. Okay? Say, hello, little Susie. Little Susie has these things on her head right here. They're called ears. She hears what you're saying.
Oh, that's so cool.
Okay? These are special devices. If she hears you, she computes it and converts it into a text message in her head. Then her reply, instead of texting it, will come back out of her mouth and she'll say, hello, little Joey.
Oh my God.
Everybody got that? What's this called again? Mouth. It's used to communicate back and forth.
How do you go to someone's house?
She goes, how are you going to go to someone's house? We have these other devices. Hello. We have these other devices that allow you to go to their house, and they're called legs. You have to stand up.
You walk into the house.
And you walk like this. Okay?
Do that.
Everybody got that emergency kit? All right, yes, you have a question?
There's devices here. Some we fight so hard.
Well, then you have to walk far. Okay, who else?
Use a car.
Yeah.
Me. I'm old. I don't know where your house is. Sorry. That's very old.
You did. That was hot plasma. That's a solar flare that's going off right now. In both scopes, the brighter the color, the hotter the temperature. You're looking at plasma on the photosphere and the chromosphere of the sun. One more question?
Do you maybe know what day the cell phones might go off?
Do I know what day the cell phones may go out? No, I don't, and no one does. Scientists are very, very limited in their knowledge of how the sun works and when something's going to happen. All we know is it's in a... Hello? All we know is that it's in a very active period, and the chances are very high for X-ray flares today and through this period, okay? That giant sunspot is very active. The chances of it having a flare that's strong enough to interrupt cell phone or internet is very high. So it may happen today, it may not. We don't know enough to predict it. That's why we're counting on you to grow up and become scientists and put down the Real Housewives and Lady Gaga and go learn something important, okay? Well, that's what we want you to do, is become scientists. And that's about all I got for today. So unless you have some other questions, your teachers will lead you back in.
Thank you.
Let's thank Mr. Stephen with a round of applause.
You're welcome. Okay.